Hi everyone, my name is Jan. Welcome to the lab. So, the last video, we worked on scanner driver API, and I'm not really sure what we actually did, but we have a class, a common class, multiple implementations, which provides an iterator-like API. So you for scanning. Sorry, I should have said that, of course. So at a given point in time, you can always ask if we have a next token in our input stream, and then you have the ability to query it, to retrieve it out of your scanner. And maybe I will move the camera a little bit, change the angle a little bit. So, and so a lot of time you would like to peek ahead, so you don't always want to pop some tokens or like retrieve tokens and consume them from the input stream. But you would, before you actually remove it from the stream, actually peek ahead. And this is not currently possible. And so basically, I would like to work on this. And to do so, I used a little example, just really stupid. So I just hacked something together just immediately before I started to hit record. So what do we have here? We have basically, where do I start? So we have a little data structure, a little AST data structure, which should hold declarations of some kind. And then I decided to introduce two subclasses in this case, so substructs, so to say. And basically, first one will represent a function declaration, and the second one a constant declaration. And I'm using a made-up language, which of course looks a lot like C, but just to simplify, we only have integer types. And yeah, basically I don't parse actually literal, just keeping it as a string around, but doesn't really matter. So basically we have two AST nodes that differentiate if we have a function declaration or a constant declaration, and they share a common prefix. So in those cases, both start by the type integer and then a name, and then both declarations differ. So in this case, in case of a function declaration, we expect open parentheses, the next token, and here a equal sign, so just when ignoring white space. So, and this is just a very simple AST which can hold this structure. Then basically, let's peek a little bit ahead. Then I defined all tokens, which my made-up language has and knows. And I'm using, of course, the parser generator. No, sorry, not parser generator, the scanner generator library that we developed previously. And basically, I introduced some constants. As I already said, really easy in this case. If I would do this if I actually would implement a scanner, a scanner and a parser, I would not use defines, but enums, but just to keep it really simple. So, and then let's look at the other code. So then I hacked together some code which currently doesn't really compile, but so I introduced a method called parse declaration, and basically this parses a declaration and differentiates between the function declaration and the constant declaration, and it does this by lookahead. So I just invented some names, and of course I introduced some helper methods which either just expect given list of token. So basically I have two usages. I could either say I expect integer token type I expect a token of type integer. So those are names of my my tokens. Yeah. So, and then I can say require, which actually returns the token. So expect just ignores the tokens. So just that this code actually makes sense. So then to pass this structure, since I know both cases are the same, I can always assert that we see an integer followed by an identifier, and basically those helper methods skip white space. So, and then I can look ahead, and depending on the token, the type of the token we are seeing, in this case equals, and in this case open parentheses, we can dispatch and continue scanning the rest basically. So, and then this production, this rule, this method would be embedded somewhere else, and that's what I'm simulating here. So, so if we had a more complex language, we could also peek ahead, and that is what I'm simulating here. So maybe I would first test if we actually can see a statement, and a statement, of course, since a declaration. Well, the details don't really matter, but I'm just peeking ahead and deciding whether I should pass a declaration or not. So, and of course, this code doesn't really compile, since this API, this lookahead consume API, doesn't really, doesn't really work, since it's not really defined. So, and of course, I could, all cases, I could explicitly handle checking whether we can peek, but this would really be trivial to do it in my code example here. So, for example, if we expect before we can actually skip anything, we could also check actually can consume. As well. And here we always look aheading, and basically we can say scanner can look ahead. So if we can look ahead, well, we might just inline this here. So while we can look ahead and our look ahead is a white space, then we can actually just skip the tokens. So basically, you could also imagine such an API with the can consume and can look ahead. Yeah, well, I like it. I will do this exactly like here. So let's work this API. So currently, as I already said, we have the Iterator-like API that doesn't support look ahead, but I would like to do some look ahead. So let's actually do this. So then instead of has next and next being public, I think I will just keep them as private methods for now. So just going to move them here, since so we have some more methods, but those are I consider them as lower level APIs, our highest level, and the highest level we will expose publicly. So so how do we want to do this? So maybe we will just include everything as stubs. So let's do boolean can look ahead. And we might also include a look ahead, an offset. so that you can also express, can I look ahead 5 tokens, for example? And then, of course, the method to actually look ahead. So, and we return a token look ahead. So, this method, and also for consuming. So, consume. And in this case, this is not really an index, but a size. So, like this semantic, I say, if we call consume with no number, always peel off 1 token. But if we say consume 2, it will consume 2 tokens, but returns the last one. So I think I want to do this as follows. So, and this one is a same API basically. So this should now actually compile. Well, should build but not link, since we didn't implement anything yet. Oh well, I missed a return value in my main, but it doesn't really matter right now. So yeah, sure, a lot of linker errors. Yeah, so this is basically every usage of my scanner in my main file. So let's actually implement something. So how could we do this? So I'm guessing that, since I would like to have, so how do you do this? So basically I would like to have a fixed look ahead, maximum look ahead. But how do we do this? Should we introduce? Well, basically, I'm thinking a circular buffer. How's it called? A circular buffer? A ring buffer, I think. I will introduce a ring buffer where the scanner reads tokens in, and those methods just work on the ring buffer. So let's model this. I want a ring buffer of token and some look ahead. So let's call it buffer, or let's call it look ahead. Look ahead buffer. I don't know how it always just begins with the names. So, and I'm moving this here, but I don't love this. But basically, those methods work on those members. So those don't work on the members, but so yeah, like this maybe. So those methods work on those members, and yeah, well, those will work on this. So the highest abstraction basically. So and this look ahead will be a template argument. But then every subclass has to deal with this nonsense. So maybe let's not templatize this. So let's just hardcode something. So of course the ring buffer doesn't exist. So how should a ring buffer work? Where do I have to put it? So offset. Okay, sure. So do we now find this? I think we should now find this include. So template. So I'm expecting a argument element type and a size. This is capacity. So let's include 4 types to see size. And this is a class called ring buffer. And we put it in the core namespace. And we export the symbol, the global namespace. So now you should see this. So let's see, what do we actually have to do here? So if we want to look ahead, 0 things. So let's hack something in. So we either basically what we have to do, we have to, if our look ahead buffer has less than offset elements, then we should try read let's say try fill buffer. And then we can look ahead if we actually have enough. I'm not sure if this is the correct operator, but so I think this is the same code here, except count to be -1, so like this. So and then I can combine this. So basically, n require index. Let's call it require offset. So and this can then do this code. We pass in the index. So now the offset. Pass in the offset. So also let's stub out this method. We can inline this. And instead of implementing this one here, we can just require offset. And well, if we want to consume one element, we have to require count -1. I think this makes sense. Not sure if I like the names, but we can always change them now later. Here we just pass in the offset. So I think like this. Of course, we don't have a size method yet. And what does try fill buffer do? So, and of course, let's sprinkle some line keywords around. So the size, we need a way to retrieve the size. So what does actually happen now? So our linker errors kind of stayed the same, and some new ones were introduced. So I think I can also implement this method now, since I think basically while the lookahead thing is not full, our lookahead buffer is not full, and we actually have a next element. Then we can and this is not only a ring buffer, but I don't know how they are called. With a write and a separate read and a separate write position. I think that they are called ring buffer, but not really sure. So let's do write. Basically next. I hate this. What if we introduce parentheses? Okay. And I now think this method is not really used, so maybe we can inline this. So let's remember. But now let's also introduce full and write. Full and write. So Boolean full. Are we full? And write. So what do we want? A token. So let's accept our element type by move, by r value. So don't know. I think the compiler might be smart enough to optimize this. Okay, sure. So now we always have. I think I'm just going to do this now. So I think we don't need this. So basically, if we don't have enough elements, we try to read, and then check the condition again, and basically, yeah, we then should have enough. So, and then, if we actually want to look ahead, we assert that we can look ahead, pass the index along, and then I think we just delegate to our look ahead buffer. So let's do read, and I want to how can we do this? So I would like to do a consume false. Don't consume like this. Maybe let's just call it lookahead. And similar, I want to do this. So let's assert that the count, so let's start by inserting that we can actually consume count elements. And we assert that count more than 1, at least 1. Else we can't consume, so basically, let's skip this for now. Like this, so for so require at least 1 token, since if you consume a with 0, you would always get the error token, since I think yeah, so this would be default constructed and this is then an error token. So just asserting that we have that we want to at least consume one thing, because then we would return a valid result value basically. So I think this should be fine. So let's also introduce this API, and then we just to implement some ring buffer function methods. So consume and look ahead with an offset. So and a consume. So I think this now compile, but of course not link. We just switch the problem. So instead of implementing the logic here, we move it to ring buffer. Fine, in my opinion. So let's implement a ring buffer, I guess. So now it's just we have less linker errors. This is nice. So but this error gets on my nerves. So let's just return null pointer. So why is this unused? Yeah, local variable is always unused, since we always, yeah, I see, because we always do this. I think we can always also do this a little bit differently. We can always say like this, then if I count -1, we just well, but we always have to consume this. So we can also do this. And in this case, we simply return an error token, but we assert like this. But in this case, it would also not really make sense if count is 0, since size is unsigned. So size is my own type. Then this would underflow. Then we would not really. Oh well, but if count is 0, we would not enter the loop. So I think it's actually fine. So let's implement a ring buffer. Not really sure how this works. So I think we have 2 pointers, 2 indices. So first of all, we have some data. So like this, I suppose. And then we have 2 indices. So we have a write index and we have a read index. And I think we all have to also keep we have to remember whether we are full or not full, since at the beginning, write and read, both indices point to the same position, but we are not full, we are empty. Yeah, I think like this. So let's see. Let's capitalize this. So how do we answer the question whether we are full? So we are full if we point to the same position. So if read equal to write, and if we are marked full. I think we can also do empty, since this is this basically. So if we point to the same position and we are not marked full, then we are empty. So we start out with this state. So, but what's our size? I think our size is just, so if we are full, then we return when our capacity is our size. Else, I have to do some math. So let's draw an image. So let's draw something. So we have a ring buffer, so let's draw it like this. Let's introduce 2 little arrows. Let's say a dark and a light color, so like this. Let's say that our blue is our read arrow, and let's say red. Don't know which red I used for right position. Okay, beautiful handwriting here, so perfect. So, and let's say, so at the beginning, our size, and just subtract those indices, but which from which is the question. So, but if we are marked full, we just return the capacity. Okay, fine. So let's say we wrote something. Then the what? Well, I have to remove tool. We wrote something. Then I can just I think I can always select right cursor from the read cursor. But the read cursor can be before the write cursor. Yeah. So basically, I have to wrap around. So can I just always following? Can I just do write plus capacity? Yeah, minus read. And then normalize this by mod, using mod, like mod capacity. No, not bitwise and mod. Like this. Isn't this what I want? Well, let's think it through a little bit. So this would not be a problem, since write plus capacity, since I'm always modding capacity. So let's start by this case. Those are both 0. So in this case, write plus capacity would be capacity minus read would still be capacity. Capacity mod capacity would be 0. So this would be fine. Size would be empty in this case. But if we actually did write something, then we would write plus capacity would, for example, be, let's say capacity 16, then it would be 17. Minus mRead would be 0, since we did not read anything. Mod capacity would be 17, mod 16 would be 1. Be also correct. But what happens? Actually wrote, but did not read. So in this case, we would do write would be 1 plus capacity would be, let's keep 16. 1 plus 16 would be 17 minus read. 17 minus read would in this case be 17. So this would be 0, 1, 2, 3. 0, 1, 2, 3. 17 minus 3 be 14. 14 mod 16 is still 14. This is correct. So I think this should wrap this around. So I think this will work. So to write a value, I'm currently thinking of just defining all those methods out of line. So after the class declaration, I think I'm just doing this for now. The interface is a little bit cleaner than, and I failed. I somehow overwrote my clipboard. Or can't I just, well, this cut? Like this. No, would be fine. So, and I'm now going to repeat this for all methods. So if we are empty, the pointers share the same position and we are not full. So of course we have to handle this. This is always false for now, and write and read is always 0, but I think we will do this now. So I think I will always, well, let's ignore this. So to write a value, how would this work? I think I can just put it in the right position. So I know. So let's start by actually by including utility, since we need std move, and we need assert, since I want to assert now. So let's assert that we are not full. Because if we are not full, we can append a single element. So, and to assert a single element, I can just write in data. So into our right position, we can std move our value. And then I can advance right. Advance doesn't exist yet. And then if now, after advancing the right position and the read share same position, then we are full, since we just wrote a single element. So I think now we actually took care of our full flag. So of course we need now need an advanced method. So this will be a private helper. It will accept an index. So in this method, we'll just basically advance index and then just wrap around. So just mod capacity, and it will reassign to index. Okay. So now we should only get 2 linkage errors. So look ahead and consume, and yeah, so 2 linkage errors. So to consume a value, think this should be the easy case. Let's start with this. Because it should basically be symmetric to this case. So if we are not empty, we can certainly consume a single value. We can read we can std move our value out. Then we can advance the read position. And since we just consume a value, we should not be full anymore. But I think this may only make sense if capacity is not 1. So a ring buffer of size 1 doesn't really make sense, so I'm just ignoring this fact for now. Okay, sure. So consume the simple case. Let's work on this. Okay, and this API. So to look ahead at this index, basically I have to wrap the index around. So I think, let's just write it out. Basically just have to read. So like this. But here I have to wrap around as well. So not really this, like this, I think. So I can just return this. But this wrapping around, I don't really want to share this code. So this also wraps. Let's refactor something. So I think advance can be static, since it only works on its parameter. And this one can also be static. So then I can just call wrap here. Also here. Then forget to return this actually. It doesn't really make sense. So, but now I really would like to I think I can now inline this as well. Those methods just got too easy. So, but I really would like to assert that this index is actually valid. So, how would this look like if write plus capacity? Yeah, I know. So I think I have to do this as well. So we still wrap around, but we also add our capacity back in. So we get now a wrapped index. This, so well, read. Now I have to do this with write. So if write is greater, does equal also count? When is the case? When can't we look ahead? If we are empty. But also, let's see. So we can look ahead if our read less than write. But check this. I think I have to do something like this. So if write what did I say? If write so let's rethink this through. So this is an empty buffer, but we cannot look ahead because we are empty. So let's just insert this. If we are not empty, we can't look ahead. So now wrote something. We wrote something. Then the difference 1. And we can. I think I know what to do. So I think we have to do this as well. This again. Now. So this is the size. Oh, well, we actually just use the size. Size. Oh yeah, I think I know what to do. Now we can just read, do this wrapping trick. If our read pointer is less than our size. Correct. Let's just throw it in and test it out. So I think now it actually should build and link. And it did. Let's run it. Ah, well, that didn't really work. But I would not have expected it to work. So line this, we can't look ahead. So okay, cool. Crashes. But why doesn't it hold? So when do we get here? Do we get here immediately? Okay, we get here immediately. So then our size should be 0. Is this correct? I forgot something. I forgot something. I actually have to give it some input. So let's give it this string. And see what happens. But it fills our ring buffer, I think. We fail at the same position. I think then our size method doesn't really work. So this works first. So I think this doesn't really work. But we made some progress, so this should be filled. So let's see, what does our size method do? Jump there. I think we should be full, but not full. Why are we not full? We are not full. We are not full. Then so this should still be 17. So my capacity in this example is 256. But 17 plus 250 minus 0 mod 6 still be 17. So then get 17 back. 17. Oh, I switched this around. Derp. Well, stupid. But I think so. This looks fishy. So the offset is size 0. Size is 0. Ah, yeah, I think this is correct now. So now we require the offset. Okay, we fail at the same position. But why? Time for some printf. So maybe let's move one step back, and let's just test our data structure out. So our ring buffer of, let's put integers in here, and let's use like 4 in this example. So let's write one. Then we should be able to assert that buffer size is 2. Then we can look ahead should be 1. But the size should not be changed. If we then would buffer consume, would be we would see 1 again, but our size should be decreased. Then if we look ahead one more, we would see 2. And then buffer should be empty. So does this work? What? Sure. The buffer now contains 2 values. Our write position is at 2, at index 2, and read at 0, and we are not full. So our size is 2, this worked. We look ahead and see 1, our size is still 1. We consume. So now we consume, so the read index got advanced. Then our size should be 1, and it is. And if we then look ahead, so next time we consume, this doesn't work. Okay, so this is an error, and this expression failed. So let's do this. Oh, this is not correct. So basically I have to do something like this. If the read position must be smaller than the write position. The write position can be in fact void, so we have to wrap it. This, we have to include the offset, like this. Same here. So this one works as well. So this assert fails. I failed. So this is expected. Oh, now it should be. Now the test actually works. It terminates. Okay. So this would be perfect to turn into a test. That's why I'm keeping this code. Well, I can just fill this. We don't have any tests for our core library, just for sigil. Okay. So we fail this assertion, line 53. This assertion fails, but why? Or can look ahead via offset. So let's actually bust out some printf debugging. So let's see if this actually helps. Doesn't really work. Boolean. Okay. Why don't I have a formatter for Boolean? Weird. I don't have. See. Should be fine now. Little bit wild. So basically our problem is that at the first call, our size is less than the offset. Then we'd write something, then it is still correct. So does the size method not this work? Let's see, if we write something, we advance our right pointer. And then the offset is less than the size. So this could be 0, like 0 to 5. Use it. This should be fine. Offset is less than size, look ahead size. then we can basically read. Okay. Not full. As long as we are not full. And we have a next token. Read the next token. Remember it in our lookahead buffer. This should be fine. And then what does size return? This could be wrong. Let's actually print this. Let's just print it. This doesn't work as suppose. Okay, it returns 0. Can we set a breakpoint here? So where are we? We are here. So first size, I expected it is 0, so I'm just skipping this. So here we return, actually read something that should be able to confirm. Oh. Why? Did not write anything, didn't we? Wait, what is the problem? So we entered this. Did we actually call next? We did not. We somehow skip the loop. So first, get here. So offset. No. I derped again, I think. So the size is less or equal. I think this was correct. So I swapped this, I remember. But I think I double derped. So first, the size is 0. This is what I expect. Then now we write something. Now the size is actually 17. Let's remove our debug prints. Here. Ah, so slow. I'm building with J8, yeah. Okay. Does it work now? Aha. But this is still the same line. So we get here with the offset 0, get here, try to read something, 17 elements. So basically we try to fill this buffer. Should now see this buffer. And just look into this, please. So then we should see some token. So this is white space, I think. Integer. So we actually get our tokens. So and I think we have 17. So this one is the error token, but this is white space again. Here is closing parentheses. So basically we have our token. This works. But now offset is 0 and size well, this doesn't work either. So if our size is less or equal than the offset, then we have to fetch. But then our offset has to be less than size. Is this correct? So let's see. Offset is basically a index. Well, there did I double derp. So the offset is a index. And the fetch. Then we can check if the index is in range. So like this. I think this should be fine. Yeah. I double derped. Because now we can actually look ahead. And I think we should now pass. Ah, well, our look ahead failed since we have a white space in between. So let's skip white space. Then we can look ahead 0 and 1. In between, we expect white space. So let's actually fix our little example. So basically, white space get coalesced. So we can just handle this. This should be fine now, I hope. So let's see, what do we print? Oh, we print nothing, but we crash. Now we don't crash. Okay, we don't crash anymore. Weird. Okay, sure. think we gotta fix this when it happens again. So let's see. So we don't see this declaration anymore. Already left the scope. Well, I want to do this stop. Okay. So now we see a declaration. And what type we have? We have a constant declaration. So basically we're trying to, this is not correct actually. They return the wrong literal. But this is just a stupid example. Maybe there are some errors. Function declaration and constant declaration. In the function declaration, I say we are type function, and in this case, type constant. But do I actually return the correct type? Function declaration. I mixed this up. So if we see an equals like this case, of course I have to return a constant declaration. This case, a function declaration. So just in derp on my end. Okay, sure. So now we are of type function declaration. This actually works. So let's cast it. Our function declaration, just to peek into it. And then we should see our name test. So this is a string view. It renders the rest of the string, but we actually just look at the first 4 characters as this data structure our string view says, then we see test. The value, of course, is 2. So I don't pass it here. I just keep it as a the lexeme around. So the value that was actually passed, and this was also a 2. So this works perfectly. So now we support lookahead basically. So this is what we actually did here. But on this stupid example where we have to differentiate between those 2 cases, and we do this by using lookahead, the lookahead function, which we currently which we introduced. And also lookahead we support lookahead of more than 1 character. And I think we hard-coded it to like 255. Yeah, okay, 256. And then it will just fail, I think. Maybe we can just, let's assert that offset is less than or equal to lookahead. Since this would not really make sense. So if I try to look ahead more than this value, this will fail. So we just assert this here. So, but now we can look ahead a lot of tokens. This should always be enough to 256. If not, I run into a problem, I will just parameterize. Or maybe we'll just do this now. Don't really care. So let's template. Let's introduce look ahead. This here, but let's use our 256 as a default value. I think sensible. So then I don't find this here. And I think it should just fall into place. But of course I have to fix the subclasses. So now scanner driver expects a template parameter. We will just pass this in. We have more. Now everything must move into the header since it's templatized. So we abort. I don't want this. Oh, this was a little bit too fast. I want this. I don't want this. Let's keep it like it is now. So we just hard code this. Should be fine. So, but let's see how big is our scanner class now, since now introduced a look ahead of 256 tokens. Let's print the size of the token. This is size of stop. So where is our token defined? It is a nested class in scanner driver token. How big is a token? How big is our scanner driver? So this is an abstract class, but every class which inherits from this has at least this size. Oh, it's actually a big boy. Since let's bust out a calculator. So if we have 72 tokens, a single token is 72 bytes size, and we have 256 of them. Now this is where the size comes from. So let's see how big. Well, I wanted to do 72 per token times like so many. So scanner driver is 200 bytes, but with the look ahead, it's quite big. Do we care? I think we don't really care. Can I somehow compress tokens? How do we compress them? Let's think. So we have a type. How big is this? String view is a pointer, a size. So this should be 16 bytes. A file range. I see. Maybe we can compress it by using 32-bit file position. How long is a file? One line shouldn't be so long, certainly. I think it's, oh well, let's just all this should be fine. So you can basically pass. Maybe let's keep this as a thing to think about. So I don't want to move out. So a look ahead. Holding 256 tokens, actually really big. So size of token, which is 72 times 6, this many bytes. I can actually just use like 32 tokens. Let's just look ahead. Let's limit the look ahead to 32. This should be fine. Also, 16 should also be fine. So now our scanner should be a lot smaller. So let's just not care about this. Oh, but now we fail. This number looks a little better. But now this look ahead fails. But then I tried this out. So this third fails. Let's set a breakpoint. Wait. If this is empty, fail. But it can't be empty. This is handled elsewhere. So we have a ring buffer, which is, it is full. Okay, I see. So what is offset? Offset is 0. Oh, this assert only works if we are not full. Okay, let's do this. If we are not full and damn it. Can't type. But we still fail. I think I dropped. I have to do this. We are either full or this expression is. Let's do this. If we are not full, damn it. So I think this is not really correct. And why? So we are not full. Isn't this just checking the size? So I think this is just checking. I just have to check the size. I see. So now we can actually build a parser useful. So this parser isn't, but you can use it to write a useful parser library. Oh, yeah, quite pleased. I have to say, I'm quite pleased. So now the API. Let's actually do this. So let's resurrect our old main. I'm just going to nuke this code for now. So here somewhere should be a main. So let's resurrect this and just rerun our test. Of course, the test old code doesn't work anymore since we changed the API. So while we can consume. So what do we run here? So we read a file. We are scanning this file. We're just timing how much we. So let's see. Don't know how long we used to take. I think we were faster the last time. So without the ring buffer thing, 17 seconds, quite long. I think the last time we actually scanned in like 5 seconds. So I like the look ahead, but I don't like the performance lose. What if our scanner is smaller? Or is this just because I ran it in debug? So this is slower. So I would like to see what the problem is. What if we just say we would like to look at 4 tokens? Is a smaller look at really better? So at least a longer, bigger look ahead makes runtime worse. Maybe since our tokens, I think our tokens might be so big that fall out of cache line, have a lot of cache missing. But I would have expected that since we always try to fill our buffer, this should be in cache basically, since this method Oh well, it is not really. So I mean, this accesses our scanner, our scanner driver table. This can get quite big. Then writes to our lookahead buffer. So I think switching between those contexts would almost always result in a this buffer can get quite big. So let's make this API private. Blah, 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 blah. So instead of, so this is also public. Okay, let's ignore this. Now let's use the old API. So let's do has next. Has next and next. Let's not use the lookahead buffer. So let's measure the time, how long it takes out the new API without the lookahead buffer to actually get comparable results. Hello? 18 seconds. So it takes the same amount of time. Maybe this was running under release. Maybe I timed it under release. So I'm not really sure why this takes longer. I had a time of 4 seconds in mind, but maybe I was wrong. So like 13 seconds, 13 seconds, 14 seconds. So maybe I should say I'm reading a file which is quite big, and so I'm reading it into memory, and then I'm running the scanner on it and just measuring the time, how much it takes. Basically takes like 13 to 14 seconds. The old API. So let's actually make it private again. Or should I just expose both APIs? Sure. Since they are not really compatible. So you can't use the new API bind old one. So let's switch back to new API. Let's measure again how much it takes. So let's maybe remember that the old has next API took like 13 to 14 seconds. So it feels longer, Well, it was almost double the time. What did I fuck up? If I look ahead of 4, that's a bigger look ahead, like 32. What's actually the shortcut for running? So it's Control Shift D for running, and not Control Alt Shift D and Alt Shift X. Okay, sure. Okay, 22. So it gets lower. What if we actually use a ridiculously huge lookahead buffer? Ridiculously. Not that ridiculous. Well, you see, I mean, we don't take too much memory. I think fine. Like, that is, I hate this. So where do my 5 seconds go? Maybe I have to profile this a little bit. I'm doing this off screen. Let's try what happens if we actually take an even bigger look ahead, like let's use 10K, not 10K, like 1 kilobyte. Not 1 kilobyte, 1K elements. Like try to pass a huge file. I mean, like 13 million lines, I think. Well, it doesn't really change it. Or is it all the inlines I've sprinkled around? So how could you select the next occurrence? I double check, recheck. Forgot it how to do this. Select next occurrence. Go to next word with find next occurrence. Add selection for next occurrence. Alt Y. Okay, perfect. Yes. So did this change a thing? So we're using the new API without any explicit inline statements. The compiler should be smart enough to actually optimize this. So that actually made it a little bit worse, but not really. So I think it is measurable. Like 1 or 2 seconds. Of course, this is not really precise what I'm doing here, but better than not looking at the runtime at all. I mean, so this is of course unrealistic. So we started by 13 to 14 seconds, and we gone up to like 21, I think, if we use a more realistic lookahead size. I don't know. Now it took 30 seconds. Maybe I ran in debug. Not really a little. But it's even slower now. 26. Started with half. What? actually do we use for our scanner here? Using the yeah. We run on our A scanner. Yeah, I see. So maybe scanner that's table. How do you do this? Got the static, it's called static table. I can just so I'm using the slow simulation mode. Maybe at the times so that's other implementation. So maybe, as I already said, maybe I had times from the other scanner in mind. So we're just generating a big table, just the table we plug into our scanner driver, which is a different implementation. So this one uses the DFA to simulate, and this generates a table. Maybe I had those times in mind. Maybe not. But this is also lower than I've had in mind. So let's put those. Let's the old API public again. Let's just poke this code. Keep this line. So if we have next, we have next or next. So let's time the old implementation. This is what we are currently running. Yes, I have to flush screen. 16 seconds. Table. So this is also really slow. I mean, it's just parsing. Just scanning. Okay, like 50. Okay. Of course, table could be smaller, but so maybe it just doesn't really matter. This is just a parsers generator for development. But I'm quite shocked. So I thought it would be faster, but maybe I have to just profile it a little. So let's ignore it for now. I'm currently looking at the file which you are reading. The file I can't find. This file is like 35 megabytes. So this file we are scanning, just copy paste it, 13 million lines, but it doesn't show any lines. Thank you, line. At least Notepad shows something. So this is the line count, like 10 million. No, not really. Like, oh yeah, 1 million lines. So always the same crap. Actually, show me. Well, but I think this should run really fast. Actually, it should be a lot faster. So I think somewhere we should have a performance problem. Maybe let's just select what we found. So can consume. So I actually forgot how long this takes. So this is called DFA table scanner driver, called static table scanner driver. So let's just rerun. I think computer is quite laggy today. Also, my camera lagging behind. Really sorry. What is my computer doing? I think it not do anything right now. I just killed Discord, which was running in the background. It is a little bit smooth. So let's just run it one more time. Seems like it was Discord. Let's say like 13 seconds. Also like 13.4. Actually doesn't really make a difference. So now I should actually run those tests again to like just to have them comparable, have comparable results. What are we running? The simulation. Oh, well, so this was debug. Let's just run it. So not starting it at the debugger. So let's see what we get. Yeah, it was 10 seconds. So we dropped a little bit in performance, but we have look ahead. Maybe I will just expose both APIs, but those are strictly exclusive. Well, now 9 seconds. Oh well, it's more like 10. So it is faster. 10 to 11 seconds. Well, that was a little longer. Really fluctuating times. Like 9 seconds. Well, this is more like 10. So let's just keep it like this, and if I switch this out, this scanner implementation using our table and the old API, of course, this API does more things. So I think this is just the reason why it is slower. It not expected it so long, like 10 seconds. And let's just rerun it a couple of times. So, but now those results are comparable. So I mean, the old API and the new API, this is more like 9, not really 10. That doesn't need to be precise here. The new API is always slower. A little bit, like 3%. No, like 30%. Well, this is quite bad. 8. Well, this is more like 9 seconds. Closer to 9. Like 8.59 seconds. Of course, the table approach is faster. So this is what I have expected. 9 seconds. Okay, since those runtimes, let's actually measure the static table. So this is what we're currently running. So just to limit ourselves. Now let's play. I think I just run it twice. So maybe let's rename this to old. Let's use a copy. Should have done this earlier. So in this new, and here we're just running the old code. New. Let's say old new took. That's just to compare that. Now old and new. Of course, it uses the same scanner variable, but resets it. Just the first line. I think now it will be a little bit easier to compare the times. So of course a single run is now longer since it scans the file 2 times. Now the old took 8 seconds. Points. The new took 12. So now it's a little bit more comparable. So of course this is not really nice. So this is like how much slower? 8 to 12. I mean, like 40% slower for 40%, 50% slower, approximately. So this is not really nice. Now let's see. We're using a lookahead of 32. We have to document 32. So let's test other lookahead. So let's see smaller lookahead. This, of course, constraints our language that we can pass only can have kind of that I want to do fine. So like now we have similar times. On again. Was 8.8. Now we're taking a lot longer. So now we took let's just rerun it a couple of times. Eleven or like 12 seconds. That's actually update the range. New code. When is on? This is quite long. Oh, that's instead of 16 or 32. But how could this hold time so drastically? Caching, cache line, cache consistency, cache friendliness is what I wanted to say. User a new member, quite big. To look ahead. Maybe this is the reason. So in this case, actually, new call is faster. Move this ring buffer and so maybe I will just do this a little bit off screen. Tell you what I found. Getting quite boring, also for me. So I'll bore you. I think I will look into this a little bit more, but our basic feature works as intended, but we're just still looking at our happy surprise. So what did we do today? I prepared a little example which uses lookahead for parsing, for scanning, sorry. Then we adapted the API to support lookahead. Basically you can pick how many tokens you want, future basically, and well, we hardcode the limit to arbitrary word, arbitrary value that we just pulled out of our ass. But yeah, so maybe let's do a commit session. What did we do? We added a formatter for Boolean. Come on. Add template specialization. Specialization for Boolean. Specialization, yeah, looks correct. So, and then maybe we will keep this API for now. So let's just keep the old and the new API for now in this commit. And the ring buffer. Let's commit the ring buffer first. So let's just look through this. Looks fine, no debugs. No debugs, I think. Debug log. No debug log, okay, sure. This class is a simple fixed size ring buffer. Yeah, that should be it. So, and then of course the changes in our scanner driver, and I think I can kill this include. I don't need to print our header. So maybe let's just add it like this. Where do I have our finding? So okay. Then well, I can copy it. Capability, look ahead, scanner drivers. Our the old API, old Iterator-like as next. And well, let's not name the types symbols. The old API still exists, still used. However, should not gather new API. Oh. Look ahead. Look ahead API, which is inner driver. Okay. Can look ahead. Look ahead and consume. Or might profile it. Slow down and eventually deprecate an iterator-like guy. So maybe like this. Maybe let's put the bindings in. So where is it? Like this one. So in our benchmark, approximately 1 million lines. How big was the file? Like 35 megabytes. Like 35 megabytes. So I'm not sure if it is MIB or megabytes. What did I do? I switched the buffer. Yeah. Pairing the old and new count. So let's just paste it in for now. Iterator-like guy. And look ahead guy. Ahead of 16. Let's just keep this concise notation. So, oh well, I just moved the mount. So using a maximum look ahead of 16, we're in this range. Oh, this is actually correct. Like 8, 8, 12, 5. Sure. But we are currently running in different I'm getting tired. I'm not really remembering what we actually did here. So what are we actually running? We are running like with a lookahead of 64. We're getting 12.5 seconds. So 12.5 seconds. A lookahead of 4. Fine. Then let's rerun it more times, just to have a great message. Or like 12.8. Okay, sure. Why does it break? What am I doing? I should just stop. So let's do 32 here. So I'm guessing I'm finishing this off screen. Thank you for watching. Hope you like what you saw. Feature is basically finished. Like it, but it made our code slower. I'm going to look into off screen. Have a great day. Bye. See you.